Hello, hello, Advanced Precalculus. Here we are for our 1.3 notes. Graphing with the TI, or another graphing utility such as Desmos, but we're going to stick with the TI because that's what you'll use on your tests this year. So the title here, Graphing with a TI. Okay, and so here is my TI right here. Definitely going to be getting a lot of use out of these this year, and then also if you move on to AB Calc or even Div Calc, we use these quite a bit. Okay, so we're going to solve the following equation three different ways. We're going to use algebra, so we've just got this really kind of basic equation, 2x plus 3 equals 4x minus 1 plus 1. We can just use algebra, good old algebra here. 4x minus 4, there's your distributive property. Let's clean up each side. That's 4x minus 3. Let's get our variable terms on the left and our constant terms on the right. So we get negative 2x here equals negative 6. Divide by negative 2, divide by negative 2, and x is equal to 3. So that's algebra. Beautiful thing about algebra is you can always check and leave your problem knowing you've got it right just by a simple substitution in for x and see if we get a balanced equation. Okay, so 6 plus 9, is that equal to 4 times 2 plus 1? Yes, 9 equals 9. I can leave this problem and know that this is correct. Okay, so other ways you can solve this is a linear equation because it's just x. Is to use your TI to graph a system. Okay, so we could treat each side of this equation as its own equation, set it equal to y. Here's y1 and y2. Those are just little subscripts. Those are like name tags distinguishing between the two y's. So I'm just going to set the left side equal to the left side equal to y1, and then the right side equal to y2. Okay. And so to graph these with your TI here, you're just going to go on, you're going to go to y. So I've got some stuff in here from the classes, let's clear that out. So I just notice I just hit y equals right here, okay? And there's y1, I'm just going to type in 2x plus 3, okay? So that's y1, I'm going to pop down to y2, and I don't even have to put this in slope-intercept form. You know, you certainly could put that in slope-intercept form, 4x minus 4 plus 1, which is 4x minus 3. You could certainly do that, but on the TI you don't have to. As long as you have it solved for y, you can put all of this in kind of an unsimplified form. All right, looking good there. So I just picked up my calculator, so I don't know what window I'm at, so I'm going to do a zoom. I'm going to do a zoom 6. Which gives me to a standard grid, which is just, you know, negative 10 to 10 and negative 10 to 10. So I'm going to do zoom 6, which means standard. And we're going to graph these. All right? And so you're going to see right there that these, what you're asking the calculator to show you is for what x value, do these graphs intersect, the 2x plus 3 and the 4x minus 3? At what x value do they intersect? So it's going to be right here, okay? And so if we were to graph those, we would have on this one a y-intercept of 3, okay? And then we would go up to over 1, right? And so there's one graph. And then this next one here would have a y-intercept of negative 3. And then it would go up 4 and over 1, okay? And, you know, we know the answer's 3 here, so I'm going to go ahead and kind of make this happen. When this graph's up, we're going to go right there. And you're going to see this intersection point here is going to be 3 something. Okay, this problem doesn't ask you to find the y value, but this 3 and this 3, this is algebraically, this is the same 3 as right here. That's where they intersect. And so the TI can find that point of intersection by, if we go second calculate, And so what did I do there? I just went second calculate, second trace, calculates above there. And what I want to calculate is the intersect. So I want to calculate the option 5. Okay, and so it's going to say first curve. So the cursor's on this first curve. It's not a curve, it's a line, but the calculator calls it a curve. I'm just going to hit enter to say yes. And notice how it popped to the second curve. It's asking for verification. Is this your second curve? Hit enter, yes. And then it says to guess, so I'm just going to pop the cursor up to help the calculator out a little bit and just get it kind of close to it. And I'm going to hit enter again. And it's going to tell me the x value is 3 and the y value there is actually 9. This problem does not want us to find the y value, but you can see that intersection is right there, x equal to 3. So it was 3, 9. You could have also found that 9 by going 2 times 3 plus 3, which of course is 9, and you can verify on y2 that 4 times 3 minus 1 plus 1 is certainly going to be 9 as well. Okay, and then the last one would be to combine this to a single equation, okay, and just, move everything from the right side over to the left side. So you would just get 2x plus 3, and I'm going to minus off this form right here, okay? I'm going to minus off, just because it's easier. You don't have to. You could minus off all this, but it makes me a little nervous about missing sides. So I'm just going to minus off this 4x minus 3. So I want to be really careful that I minus off the binomial, both of those. If I don't use parentheses there, I'm going to miss a sign. Okay, so when you're just doing this as a really simple, if you were to clean it up, you don't have to. I could put this straight into TI just like this. But I'm going to clean it up. I just want to make sure you put parentheses here, because if you don't, you're going to get minus 4x, minus 3. And it's not minus 3, it's plus 3, because this negative distributes here, and this negative distributes here. Okay, so what we're graphing then is negative 2x plus 6. All right, so 1, 2, 3, 4, 5, 6, right? So that's your point 0.06. You're going to go down 2 over 1. And you've got this other point here, and that's going to be what, 1, 4. And what you're looking for visually here is when you set it equal to y1, you're really kind of seeing you want to solve for x equals. So when you find what x equals, it's when y has zeroed out. Okay, y has zeroed out. You want to see where y is neither up nor down. So we're looking for this right here, and sure enough, this is going to be x equals 3 right here. That's going to be the point 3, 0. So that's another way to solve, with the TI, just to get everything on one side and look as to where it crosses the x-axis. Okay, and so here on the TI clear, you would go up here, and I'm just going to go 2x plus 6, graph. Okay, and so you can certainly see that this is that x equal to 3. And so on this one, you would go second, calculate. Now we want to see the 0, option 2. Where does it 0? So the calculator's like, can you go a little bit to the left, help guide me? So I'm going to go a little bit to the left of where I see the crossing. Basically, I'm looking for a positive right there because it's above, and then get over to the negative y values because then that's below. So that's the right bound, even though it's more like, above and below. The calculator's looking at it for x, which is a left and a right movement. And so I'm going to say there, and it wants me to guess again. I'm just going to hit enter again, and you certainly see that the 0 is 3, 0. All right. So observation, the algebra approach was the shortest method and did not require a TI. But if the equation cannot be solved, like with algebra, if it doesn't come out perfectly, we'll just find approximate solutions with our TI. All right. But these weren't even approximate because these were nicely solved. All right, so let's solve some more equations graphically. Okay, so we're going to do the intersection method. And now you'll see where this little sentence comes in here. So if we were trying to solve this with algebra, so this one's called the 0 or x-intercept method. If we were trying to solve this with algebra, you would set it to 0, and that's going to be plus 4 And it doesn't factor. It does. What just happened here? My computer went off. Oh my gosh. Are you guys still on here? I don't know. Okay, that was really weird. I don't know. My computer just went off and my screen went blank and it said I was entering power saving mode. So I hope I didn't lose you guys during all that. So we'll just keep going and I'll cross my fingers that it didn't power off. All right. So this would not be able to be factored in self. So this is where we're going to have to use the calculator and then we'll get an approximate answer. We're not going to get a nice, neat integer like 3 here. So let's do that. All right. So we're going to do the intersection method here. So negative x to the 4th plus 1 and 2x squared minus 3. Okay? So let's just let our TI do the work for us. Here we go. Clear. Negative x to the 4th plus 1 and 2x squared minus 3. Graph. It's going to graph the negative x to the 4th and then the parabola, and this is what we get here. Okay, so I'm just going to do a kind of an approximate, and this was just on a, your viewing window, whatever you use. This, when you see a prompt like this, this is just your x range. So I was on a negative 10 by 10, and I was on a y range of negative 10 to 10. So this is just whatever you're telling me, you're showing me what you're using. You might want to zoom in and do something, more precise, and then you can just let me know that, but I'm just going to go for it right here. So I'm going to go second trace 5, okay, and I'm just going to say this is the first curve, yes, this is the second curve, yes, and then I'm going to push the cursor to one of the two. I'm going to have to go through this process twice. All right, so it's going to tell me that x is negative 1.112. All right, so there we go. So x here, let's just draw these guys. Something like this. 0, negative 3, it's right there. And this one, just something like this. This is 0, 1. And so this first spot here is negative 1.112. Okay, again, we're just looking for the x values here. It doesn't really want the y values here. The original problem is just in x, and so we're just going to get these x values. All right, and so let's go through the process on the second one. Second trace, intersect, first curve, second curve, yes, and then guess. So I'm going to push the cursor over here and hope it'll give me this one. Sometimes you have to really kind of force it, but it did. So this one's the positive 1.112. Okay, so over here, this x value is, I was about to write the coordinates. So x equals 1.112. So x here is equal to plus or minus 1.112. And that's an approximation, so that goes back to this. Okay, so if you were giving the coordinate pair, you would give 1.112 and negative 0.528. Okay? But that's not what we're doing here. We're just doing x. All right, so use color and label. Sure, if we find here. So, you're finding your x values. Let's go with 3 decimal places because that's what you have to do on the AP exam if you take AP Calc. So 3 decimal places is pretty good. And, always clearly show values on the graph. If we were doing the x-intercept method, we would zero it out. So I'm just going to put in x to the 4th minus x to the 4th plus 1 minus 2x squared plus 3. Okay, so this is if you were trying to use algebra, you would get it to this, try to factor, not be able to, and so you'd have to go to your graphing calculator. Okay, so remember now we're going to be looking for it where a single graph where it crosses the x-axis, and it should cross at both of these. You'll see the consistency there. So clear up minus x to the 4th minus 2x squared plus 4. And graph. Okay, so there we go. And we're going to, I'll just, really nice little rough sketch here. That is 0, 4. So we're looking for this x value, and this x value is where we would be, zeroed out. Zeroed out is where you cross the x-axis. So let's go second trace 0. Okay, and left, let's go a little bit to the left of this point of interest. I can tell I'm below by that negative, enter. Go above it, enter, and then just hit enter again, and we should get negative 1.112, which we did. And let's do it again. Let's do second trace 0. Push it over here. Now the left side is above, so I'll hit enter. You can overshoot it a little bit. It doesn't have to be perfect. You're just really just guiding the calculator, and there's 1.112 again. All right, and this was, I was on a 10 by 10. This is your x values, and these are your y values, meaning the range of them on the calculator, okay? And that's what, when I did Zoom 6, that's what I got. Okay, so this was negative 1.112, positive 1.112, x equals plus or minus 1.112. Okay, next page. Just to summarize here, we have the intersection method, the zero method, or x-intercept method. Okay, so here, let's say you have two equations. There's one equation, there's one equation. So graph y, let's let this one be y1 and let this one be y2. So let y1 be h of x and let this one be g of x. Find each point of intersection. You're going to graph them, find each point of intersection. The solutions are the x values. All right, 0, rewrite the equation here as, the left side minus the right side, one equation. Graph that and find the x-intercepts or zeros. Okay, the solutions are the x values. Okay, so they would be, x and then 0. Okay, so I'm going to go through these a little more quickly just so, because I know you can pause on your video. I'll go through these a little bit more quickly than I would in class. So just some new type of problems, solve algebraically, yay. Check algebraically and graphically with your TI. You don't have to show your graphical check. So we'll probably just go through solving these. You can kind of check them on your own just for time's sake. Okay, so what I'm thinking when I see this first problem and I approach it is I don't like fractions. And so when I don't like fractions, I get rid of fractions. So I'm going to multiply the left side by 3 and the right side by 3. That's completely legal because I'm doing the same thing to both sides of something that is balanced, and that's an equation. Okay, the left side has two terms. It has a fraction term and a 16. So when 3 distributes to 2x plus 1 over 3, those 3's knock out, and I've just got 2x plus 1. When the 3 distributes with 16, I get 48. And over here, I get 9x. Okay, so this is lovely. It's linear. I say linear because it's just x to the first power. So x terms on the left, non-x terms on the right. This is negative 7x equals negative 49. Divide by negative 7, divide by negative 7, x equals 7. Okay, check it, you guys. It checks. You could check graphing. You could graph, you could put both of these into the TI and see if they intersect at the x value of 7. Or you can throw 7 in here and just see if you get a balanced left side to a right side. Okay, next one is a x cubed, a polynomial, plus 2x squared, minus 9x, minus 18. So the first thing I think about when I see a polynomial is set it equal to 0. Okay, set it equal to 0. So we are going to try to unfactor this. We're going to use the zero product property, which basically says if A times B equals 0, then A has to equal 0 or B has to equal 0. That's your zero product property. Really basic stuff. Okay, but this is a 4-term. This is 4 terms, so we have to figure out how to factor 4 terms. And our go-to with 4 terms is to group. Okay, so factoring by grouping, again, I'm trying to get it to A times B so I can apply the zero product property. So when you factor by grouping, you group terms 1 and 2 and group terms 3 and 4. I factor out an x squared. I'm left with x plus 2. So I group 1 and 2, 3 and 4. I factor a common factor out of each grouping. And this one, I'm going to purposely do a -9 so that I get x plus 2, because what I'm looking for here is this common group. Okay, I'm looking for this common group, so I want to factor out a -9 here so that I achieve this x plus 2. Okay, so I've grouped terms 1 and 2, I've grouped terms 3 and 4, I've factored a GCF out of each group such that I get x plus 2 here. Then I'm going to factor out that binomial GCF, right? So I'm factoring out a GCF. Both terms, this is one term minus another term, and both of these two terms have a common term. It happens to be a binomial, so this feels a little weird, but it's totally, good practice. So x plus 2 parentheses is being undistributed, right? I'm going to just do a big bracket here so you can kind of see what's going on, and what's left is x squared minus 9. Okay, so I've factored out a group, and that's okay. So I can continue to factor, because this is now a difference of squares. Okay, and we get our values here. X is equal to -2 plus or minus 3. And those all check. If you went back and solved them in, so on and so forth. Okay, last one. What's the first thing I think about when I see fractions? I don't like fractions, so I'm going to get rid of fractions. So notice I multiplied both sides by 3 here to knock out the denominator of 3 here. So I'm going to multiply everything on both sides here by the LCD, the lowest common denominator, which is going to actually be x plus 1, x minus 4, and 4. So I'm going to multiply x plus 1, x minus 4, and this 4 to the left. I'll do a big bracket here just for visual clarity. Okay, and so this is going to distribute, this whole LCD is going to distribute to both terms on the left. Okay, so just visualize what's happening here. When this multiplies in, it's going to knock out the x plus 1, right? When this whole chunk multiplies to this piece, it's going to knock out the denominator, and you'll be left with 4 times x minus 4 on the top. Okay, here we'll get a minus 5. Now when this whole chunk distributes here, the x minus 4 will be knocked out, and you'll be left with times 4, x plus 1. And on this side, you'll get 21, x plus 1, x minus 4. The only thing that'll pop off here is this, this 4. All right, so let's clean it up. 4x minus 16 minus, that's 20x minus 20 equals 21 times x squared minus 3x minus 4. Did a quick FOIL there. Okay, we'll just clean up a little bit while I'm at it. This will be 21x squared minus, 63x minus 84. Let's go to this side. Add in 16x, add in 36. We are left with 21x squared minus 47x minus 48. Okay? And this is pretty obnoxious. We're not going to give you one like this on the test to factor, but it factors like so. Plus 16 and minus 3. Okay, so don't stress about this. Can't see it. Don't stress about this factoring. Any problem is eligible mathematically, but I'm not going to give you one like this to factor on the test. This is fairly obnoxious. But you can see that 21x times x is 21x squared. This would be this 63x and this 16, which would be the minus 47, and then that would certainly create that negative 48. So our answers here are x equals to negative 16 over 21 and x equal to 3. All right, so there you go. There's your notes. That's the end of the video, right at 25 minutes. So I'll see you guys when I get back, and I'm going to cross my fingers as I replay this that the whole thing recorded. Okay,